Okay, picking up more in behavior. And again, it's going to be the same sort of thing, but I think in pictures. And so what I was doing here was setting up the picture that I'm going to think of. So same idea on the next one here. My degree is 8, and what I care about is that 8 is an even number. My lead coefficient is 3. And what I care about there is it's positive. So I think of a little example, a much simpler example than the problem I'm given. So y equals x squared. There's an example of that. And we all should know that there's the graph of the x squared. And so that tells me that my end behavior is rises left, rises right. That it rises on both sides. And the last one for now, my degree is 6. What I care about is that that's even. My lead coefficient is -3, and what I care about is that that is negative. So a little example that I think about would then be y equals -x squared, because that fits that, even, negative. And we know that the graph of that is the upside down parabola, so to speak. And so my end behavior is falls left, falls right. And again, I think in pictures. This is exactly how I do this. I think even, I think negative, I think upside down parabola, then that gives me my answer. Now, anything can be happening in the middle, but I know either end is going to look like that. Who knows what the middle will look like? But either end is going to go down. Okay, the word for today. Zeros of functions. The zero of a function f of x is a number c such that f of c equals 0. That is, a 0 is a number that when substituted into a function yields an answer of 0. To find the zeros of a function, solve f of x equals 0. That is, set the function equal to 0 and solve. Also, remember to find x-intercepts of a function f of x. You solve f of x equals 0, or you set the function equal to 0 and solve. So up here we have to find a 0, set the function equal to 0 and solve. And then later on we say x-intercepts, set the function equal to 0 and solve. So I'm doing the same thing. For a 0, I set the function equal to 0 and solve. For x-intercepts, I set the function equal to 0 and solve. I'm doing the same thing. So they must be the same thing. And that's what we have here. This means that the zeros of a function and the x-intercepts are essentially the same thing. Now I have essentially in quotation marks. There is one small difference. The one small difference is a 0 is just the number like 12, maybe it turns out to be. And the x-intercept is the point. So the 0 would be 12, whereas the x-intercept would be the point 12, 0. So there's just a small technicality in the language. The 0 is just the x value. The x-intercept technically would be the x value and then 0. So if my 0 was 12, my x-intercept would be 12, 0. If my 0 was -5, my x-intercept would be -5, 0, the point -5, 0. I'm not going to get into that level of technicalities. If you want to think of zeros and x-intercepts as exactly the same, yeah, I'll let you think that. They're not quite exactly the same, but you can think that if you want. So we got a statement down here at the bottom. For a function f of x and a number c, if one of the following statements is true, then all the statements are true. The number c is a 0 of a function f of x. 2, f of c equals 0. 3, the point C0 is an x-intercept of the graph f of x equals 0. What I'm trying to tell you here is all of these things mean the same stuff. If I tell you a number is a 0, that means when you plug it in, you'll get an answer of 0, and it also means you found an x-intercept, that all those things are the same. So let's do some work with these guys. Find the zeros of the following. So as soon as I read that, that tells me set equal to 0 and solve. When it says find the zeros, that's what I need to do. Set equal to 0 and solve. So 0.1 times x plus 4 times x minus 3 quantity squared equals 0. Now there's an easy way and hard way to do this. We'll go with the easy way. Easy way first, I'm going to get rid of that 0.1. And so I'm just going to divide both sides by that 0.1. And so I have x to the plus 4 times x minus 3 quantity squared equals 0. Now there's still an easy and hard way here. The hard way would be multiply all that out. But the thing we want to remember here, to get to the easy way, is this is factored and equal to 0, so it is, quote unquote, legal to split up. And we'll put split up in quotation marks too. Remember the zero factor theorem. So that if two numbers multiplied to be equal to 0, if a times b equals 0, then either a equals 0 or b equals 0. That when two numbers multiply to be 0, one of them must be 0. Well, here you've got things multiplied to being equal to 0, so I can split it up. That idea of splitting up is only legal when it's factored and equal to 0. So I get x equal negative 4, and then if I really wanted to beat, no, I'm not going to do that. I could rewrite that as x minus 3 and get 3 and 3. And so there are my zeros. And we have down here at the bottom, note that the 0 x equal negative 4 appears once, while the 0 x equals 3 appears twice. This is called multiplicity. The number of times a 0 appears in an answer, that's the multiplicity. And so we say the multiplicity of negative 4 is 1, and the multiplicity of the x equals 3 is 2. And so this has multiplicity of 1, and that has multiplicity of 2. But all multiplicity is how often that 0 applies when you solve out the equation. Okay, working with this some more, this example, get to the next page. And so the function 0.1 x plus 4 times x minus 3 quantity squared has zeros of x equal negative 4 with multiplicity 1 and x equal 3 with multiplicity 2. We already saw that. The function could be written as follows, where all I did here, and then we'll zoom in a little bit so we can see it a little better. Yeah, could be rewritten. And so you might be looking at it, say, that's the exact same thing, and it's not quite. So over here, I do not have an x. Well, it's up here, so I can look up here. And so it could be rewritten. And so I made one itty-bitty tiny difference. I put an exponent of 1 in there. So there's the itty-bitty tiny difference. But the point here, the 0 of the x equals negative 4, read it again. The 0 of x equals negative 4, whose multiplicity is 1, resulted from this factor, x plus 4 to the first. And notice that the multiplicity of 1 was the same as that exponent. And similarly, the x equals 3 came from this guy right here, x minus 3. So the negative 4 came from this one. and then the multiplicity was the same as the exponent. Same thing here, the x equals 3 came from this factor, and the multiplicity was 2, and that resulted from that little exponent right there. And so you can, when something is in its factored format, and this is important, this is all in its factored format, when it's in its factored format, you can read off the multiplicities by just looking at the exponents. And then the further thing we can notice the 0, negative 4, was the opposite of what we saw there. X plus 4 gave us a 0, negative 4. Here, x minus 3 gave us a 0 of 3. So we can actually, when it's in its factored form, you can read off the zeros really easily by just taking the opposite of each one of those numbers, and you can get the multiplicities by just looking at those exponents. There I graphed it for us. And so and remember, zeros and x-intercepts are essentially the same thing. And so indeed, I have an x-intercept at negative 4 and an x-intercept at 3, that my zeros were negative 4 and 3, which then are essentially the same as the x-intercepts. But I want to notice a little bit more, that at x equal negative 4, the graph crosses the x-axis. So there's my x-intercept, my 0 of negative 4. It's crossing the x-axis. And at x equal 3, it does what we call touches and turns. That it comes down and it's coming down to 3, touches and turns and goes back up. That is another thing about multiplicity, that the multiplicity determines whether the graph is going to cross or touch and turn. And so we have this little fact down here. If the multiplicity of a 0 is an even number, the graph touches the x-axis and turns around at that 0. And that's exactly what we saw at x equal 3. The multiplicity was 2, an even number, and the graph touched and turned. If the multiplicity is an odd number, the graph crosses the x-axis, the 0. And that's exactly what we saw here. Let's go out just a little bit. So negative 4 had a multiplicity of 1, which is odd, and at negative 4, it crossed. So the fact you want to remember is that if it's an odd number, the graph is going to cross the x-axis. If the multiplicity is an odd number, the graph is going to cross the x-axis. If it's an even number, it's going to touch and turn. Odd multiplicity, cross. Even number, touch and turn. And we'll end that video here.